Okay, so I want to do a video on graphing trig functions. This is supposed to kind of review a lot of the concepts that we've just barely introduced to you. And I know that there's these resources online like Edpuzzle and things that'll pause the video automatically for you. Um, and maybe it's because I'm lazy, or maybe it's because I want to teach you the skill of becoming an independent learner. I'm not going to pause this video for you, but I do recommend with these things and um, with the instructional videos that you watch going forward, you do use the pause button when it asks you a question to try it on your own first and then look at the answer. I think you can fool yourself into thinking that you're learning just as much when you're just kind of silently taking in somebody's explanation of a problem. But realistically, you're always going to learn more if you try something first and then go and then look at the explanation. Anyways, that's my speech. So the first one is y is equal to 2 sine of x. Okay. And what I know is that this is going to make some kind of a wave. It's going to have a peak. It's going to have a bottom. It's going to have these features called amplitude, and it's going to have period. Okay, and so the amplitude is easy. That's this value right here. It's going to have an amplitude of 2. And it's going to have a period of 2 pi divided by b. Okay, and the b value is the number that's the coefficient on the x that's on the inside. In this case, the coefficient is 1, so my period is going to be 2 pi. Okay, so if I'm graphing this, one thing that I need to know is that because it's a sine wave, it's going to start in the middle. It's going to have a period of 2 pi, so I'm going to label this as 2 pi, which means this is pi. It's going to end where it started, meaning that after it completes one full revolution, it's going to be right back to where it started. And since it's sine, when it's in the middle of that revolution, it's going to go through the middle again. Okay, it's going to go up as high as 2, and it's going to go down as low as negative 2. So if I graph this, it's going to look like this. And if I were to keep going, maybe this is 3 pi, it would keep going in this same shape, in the same pattern. Okay. Let's try another one. I want to graph y is equal to sine of 2x. Okay, so now notice that the coefficient is inside of the function. Okay, so my amplitude, the height, which is the amplitude, is the distance from the middle of the wave to the top of the wave. The period, you can think of it as the distance between two peaks of the wave, or the amount of time it takes a wave to complete one full cycle. So the amplitude in this case is 1. The period is going to be 2 pi divided by that b value, which is 2. So my period is going to be pi. So there's a couple ways I could do this. I could make this pi and make this 2 pi, like I did on the other one. My scales would match that one. Or if I want some more room, I could just change my scale, my horizontal scale. So I'm going to make this pi. I'm going to make this pi over 2. And it's still sine, which means it's going to start in the middle. It's going to end in the middle. And at the halfway point, it's going to be back in the middle. And it's going to go as high as 1. It's going to go as low as negative 1. Okay. What happens when you change the scale is you don't get the visual effect of what's happening when you put a value inside the function. The value inside the function is changing the period, so it's actually a horizontal compression. That terminology isn't that important, but understanding what's happening, I think, is. So if you look at it without changing the scale, I'm going to make that 2 pi, and I'm going to make this pi. What happens is the wave gets compressed. And so the way I think of this is when you put a value on the inside here, it makes you travel around your unit circle twice as fast, which compresses the wave. So it gets a little bit narrower. Okay, let's try another one. Let's try one where we have a couple things going on. first of all, it is a cosine. What's different about a cosine? Well, sine starts in the middle, cosine starts on the top. Okay, so in this case, my cosine is going to start on the top. How high is the top going to be? It's going to be 3. How low is the bottom going to be? It's going to be -3. Okay, so my amplitude is 3. My period is 2 pi divided by b, which is 2. So it's going to be pi. Okay, so let's call this pi. Let's call this 2 pi. Now with the cosine functions, it's a little bit different. If it starts at the top, it ends at the top. And at the middle, like in the sine function, when I started it in the middle and ended it in the middle, it came back to the middle at one point during the wave. Okay? And that's just, if you look at this long enough, you'll start to realize that's just how it comes back to the middle more often than it hits the top or the bottom. Okay? But if it starts on the top, okay, this one starts on the top, it's going to end back on the top. When it's halfway in between the tops, it's going to be at the bottom. Okay? So, and if you want to add, and if you want to think more precisely, when it's halfway between the top and the bottom, it's going to be back in the middle. Okay, so this function is going to look like this. All right, so here would be a good one for you to pause it if you haven't been using the pause feature yet and practice it before I do it, if you're into that kind of thing. But if you're not, I can't control you. You'll just have to I was going to say, you'll just have to live with the consequences of your own actions. Now I feel like I'm lecturing, and you're probably ready for me to just get on with it. The amplitude of this function is 4. The period is 2 pi over b. b is 1/2. When I divide a fraction by a fraction, or when I divide a number by a fraction, if I divide 2 by 2, I get 1. If I divide $2 into piles of a $0.50 each, I get 4. So this is going to be 4 pi. It's like multiplying by its reciprocal, which I could just say, let's just say that this is 4 pi. Let's say that this is 2 pi. Let's say that this is a sine. Is it going to start at the top or is it going to start in the middle? It's going to start in the middle. Okay. It's going to end in the middle. It's going to, at halfway point, it's going to be in the middle. And the top is going to be at 4. The bottom is going to be at -4. And it's going to look like that. So now let's do one on, I figured let's do one on a graph that's given to you. Again, you can pause it if you feel responsible. You can try it on your own. What's new in this one is that there's a negative sign right here. How is that going to change it? Well, the negative sign on the outside is a reflection, is a vertical reflection. So if I think of what that's going to look like with a sign, the sign normally starts in the middle going up. With the negative sign on the outside, it's going to start in the middle. It's going to go down. I know it's going to go, let's say this is 5. It's going to go as high as 5. It's going to go as low as -5. Its amplitude is 5. Its period is 2 pi divided by b, which in this case was 4, which is pi over 2. So it has a very short period. It's moving around the circle very fast. It's going to start at this point. It's going to finish at this point. When it's halfway between pi and pi over 2, which is right there, it's going to be back at its middle. Okay, I'll draw 2 full cycles. when it's halfway between the two middles, it's not going to be at the top, it's going to be at the bottom. Okay, so it's just going to look like that, and it's going to keep going like that forever and ever and ever in both directions. How about if I had -3 cosine of x over 2? Well, its amplitude is going to be 3. Its period is going to be 2 pi divided by 1/2, which is 4 pi. It's a cosine, so let's make this 1, 2, 3. It's going to go high as 3. It's going to go as low as -3. It's not going to start in the middle. It's not going to start on top, which is what a cosine normally did. But because it's a negative cosine, it's going to start on the bottom. And if you think of its period as 4 pi, well, how much of its period does it complete in till the end, which is only 2 pi? Well, that's half of its period. So it's not going to actually get back to the bottom. It's only going to get to the top. And if I look at this, it's going to look like that. Although if I wanted to be more accurate, I think I would make sure that it goes through these points right here. And notice that its slope is not the same all the way throughout. This is something to notice about these trigonometric functions. It's flat. It's very flat near the top of its wave. Its steepest slope is right when it's in the middle of the wave. It gets flatter again, and then it gets steeper, and then it gets flatter again. So that's my graph there. So now here's a situation where you're given the graph and you have to work backwards and find the function. Okay, so if I'm going to work backwards and I'm going to find this function, what do I notice about it? Well, the first thing I would notice is that it's not a cosine because it starts in the middle of the graph and it's going down. Okay, so this is a sine or cosine. I would say this is a sine. Positive or negative? I would say negative because it's going down and not up. What's its amplitude? Its amplitude is 4. So its amplitude is 4. Its A value is going to be -4. What's its period? Its period is, let's see, pi over 4. Looks like its period is pi over 4. So what's the B value going to be? Well, that's a tricky one. What I know is that 2 pi divided by B has to equal pi over 4. And I think if you do some math, you get that B has to equal 8. So now if I'm writing this function, I'm going to get y is equal to -4 sine of 8x. If we try one more, this is going to look like, what's it going to look like? Is it a sine or a cosine? This is a cosine. Is it positive or negative? This one is positive. What's its amplitude? Well, let's say that these things are, let's say that they're 6 each, so that's 18. Its amplitude is 18, and its period is, well, this looks like the one that we did before. Its period is 4 pi. So what's its B value? I don't know. 2 pi over B is equal to 4 pi, which means 2 pi over 1/2. So now if I'm writing this, this is going to be y is equal to 18 cosine of 1/2 x. And then lastly, I want to do some with some, no, in the video that you guys did, you had a horizontal shift, a phase shift. I'm not worried about the phase shift, but what I am worried about is a vertical shift. Okay, I call the vertical shift the midline. It's also the average value. We're going to be getting into situations where these are modeling a real life situation. So the midline is going to be at y equals 9. So if I'm graphing this, I'm thinking here's 0. I'm going to put 9 right here. Okay? It's top, middle, and bottom. Its middle is going to be at 9. Since its amplitude is 15, its top is going to be at 9 plus 15, which is 24. Its bottom is going to be at 9 minus 15, which is -6. Okay, so I'm going to put, let's say here is 24. Let's say here is -6. It's a sine, which means it's going to start in the middle. Its b value is 2, so its period is pi. And so let's say this is pi. That's going to be back here. This is pi over 2. It's going to start going up. And it's going to look something like this. And I would draw, you can see my 24 should really be higher, which is why it doesn't look like my wave is symmetric. But for the purpose of this picture, I'm just going to leave it as it is. If I do another one, I know that my midline is the vertical shift, which is 15. The top is going to be 10 higher than 15, which is 25. The bottom is going to be 10 lower than 15, which is 5. Period is going to be 2 pi divided by 1/10, which is 20 pi. And is this going to start at the top, the middle, or the bottom? It's cosine, and it's negative, which means it's going to start at the bottom. Okay, so if I'm graphing this, let's say this is 0. Let's say this is 15. This is 25. That's 5. Here's 20 pi. Here's 10 pi. I'm going to start at the bottom. When it ends, it's going to come back to the bottom. When it's in the middle, it's going to be at its top. Boom. And let's do one more, because it's one more important concept. I know there's a lot of concepts. It's just how it is. So this is 12 sine pi x minus 5. Its middle is at -5. Its top is going to be at 7. Its bottom is going to be at -5 minus 12, which is -17. It's a sine, so its middle, it's going to start in the middle, and its period is going to be 2 pi over b, which is pi in this case. So its period is just going to be 2. And so that's what I wanted to show you in this case, is that when you have a b value that's scaled by pi, your period is actually going to be a whole number. Okay, so let's see, this is -5, this is 7, and this is -17. It's going to be here. Let's say this is 2, and this is 1. It's going to be back here. I'm going to put a dashed line because I like to do that for the midline. It's starting going up. And this is a lot of concepts in a short amount of time. But you can go back and rewatch this video, which is one nice thing. Hopefully some of it made sense.